All right, good morning, algebra students. Today's lesson is on function notation. It's 3-2 function notation. So we'll take some notes on this and run through some examples. So let's get started. So first of all, what is function notation? Function notation is a way of writing equations, and it's used with equations that do represent a dependency relationship. So write that down. It's used with equations that do represent a dependency relationship. Function notation. So let's look at an example, and we've seen this before. So we have the amount of the total bill, T, and the number of meals, M, bought. We've seen this in the last lesson. Is this a function? And yes, we say that it is a function. And remember, the independent variable is the one that causes the relationship. So that's going to be the number of meals. So meals is the independent, and that causes the dependent variable to change. So the amount of the bill is the dependent. So the bill is going to be T, the total of the bill. So function notation means, remember, you put the dependent first. So T is a function of the meals. So the dependent variable is T, and it is a function of the number of meals. So the dependency statement is that your total bill, the total bill is dependent, or a function of, dependent, or a function of the number of meals. Function of the number of meals. Okay, so this is an example. So let's see, we haven't used really function notation yet, but we can. So if we know that the amount of the total bill is 12 times the number of meals, so here we have a situation, write this down, the amount of the total bill, T, is 12 times the number of meals bought. Can an equation be written to model this situation? Why, yes it can. So we could write an equation, y is equal to 12x, or 12 times m. So y is equal to 12 times the total number of meals, and y is going to be your total cost. So to use function notation, we would use what we have up here. So your dependent variable, the total of the bill, is a function of m. So t is a function of m, and 12 times m is the equation, or the function. So this is called function notation, and really all you're doing is you're replacing the y, right, the y with this, your function notation, which is also up there. All right, so let's see some more. Okay, so write this down. It says determine the total bill giving the input value using the equation T of m is equal to 12m, which is what we just wrote. So this is our function. The total of the meals is dependent upon, the total is dependent upon the meals, and this is the function. It's $12 for every meal. So it says here is going to be our input. So remember, your input is your x variable. So that's 3. So we're going to take T of 3, T of 3. That means that's going to be my input. The 3 is going to be my input, and I have 12. Then I substitute the m for 3. So the total of 3 meals would be equal to $36. Example 2, I'm going to say that x now is going to be 12, or m is going to be 12. So T of 12, the total of 12 meals is going to be equal to 12 times 12, replacing the m with 12. Remember, this is your function. So all you're really doing is replacing the m with whatever it tells you to do. So here I replace it with the 3, here I replace it with the 12. So the total of 12 meals of the meal is going to be $144. So now look at example 3. This is a little bit different. So here you have 2, and then you have brackets T of 3. What would something like this represent? Well, all you're going to do is you're going to do the same thing. So you have a 2 here, but then you have the total of 3, which means this is going to be equal to 12 times the 3. So I take the same thing, the function notation, but then I'm just going to multiply the answer by 2. So this would be T of 3 equals 36. So that means this just means 2 times the 36, which is $72. So you'll see this a lot as well. So I'm taking the answer basically and multiplying it by 2. So for the next example, this is how you're going to see a lot of these function notation. So here we have an f. That means the function of x is equal to 2x minus 9. And then here it says find the function of 6, the function of negative 2, and the function of k plus 1. And all you're going to do is take the number that's in parentheses, whatever it's the function of, and you're going to take that and replace the x with that number. So let's do it. So we have find f of 6. So f of 6 is equal to, then I write this 2x minus 9. And then what I'm going to do is f of 6, function of 6, and then I replace the x with the 6 minus 9. So then I would get the function of 6 is equal to 12 minus 9, which is equal to 3. If I want to find the function of negative 2, I do the same thing. So I do f of negative 2 is equal to 2 times the negative 2 minus 9. So then the function of negative 2 is equal to a negative 4 minus 9. And so the answer is a negative 13. Now I'll do the next one. It's a little bit different. So now I have the function of k plus 1 is equal to, and then I just replace the x with k plus 1. 2 times k plus 1, remember you should put it in parentheses, minus 9. So the function of k plus 1 is equal to, now I distribute, so I get 2k plus 2 minus 9. And then all I have to do is do what I know with equations, combine like terms. I get 2k minus 7. So that's going to be your answer. There's nothing else you can do on that one. You can't really solve it unless you knew what k was. And they don't give you what k was, so you just have an answer like that. Okay. Okay, sometimes you'll see examples like this, where now you have different letters that they've thrown in. So don't let the letters confuse you. It's still the same exact process. So now here we have a function that's called h of z is equal to, and it gives you the function. Then it says find h of negative 3. So all I'm going to do is take and replace the two z's there with a negative 3. So let's do that. So I have h of z, but instead of h of z, I'm going to find the function with a negative 3, and is equal to negative 4, and then substitute the negative 3 plus 9, and then I solve it the same way I have. So I get positive 12 plus 9, so then h of negative 3 is equal to 21. And the last example here is number 6, and here I have an f of x function, and it says find negative 2, and I think there's supposed to be brackets there, negative 2 times the function of 3. So I take the function with 3 in it is equal to 4 times 3 plus the 5. So the function of 3 is equal to 12 plus 5, which is 17. But then this says right here that I have to multiply that answer by a negative 2. So I do negative 2 times 17, which is equal to negative 34. And that's my answer. So that is function notation. And remember, this is for equations that have a dependency relationship. All right, thanks for watching.